Hi everyone. Thanks for coming to my talk. I know it's 3 busy days and you're mostly tired a little bit, so I will try to make it not so boring. And a little bit about me. Uh, as just announced, my name is Andrii Soldatenko. I am software engineer originally from Ukraine, but currently living in Vienna. I'm working at Dynatrace as a tech evangelist and as software engineer. Some hidden part of me, I'm a big fan of CrossFit and some gymnastics, but it's not the topic of today's talk. Okay. Everyone knows that debugging is twice as hard as writing program in the first place. So if you're clever as you can, but when you write a program, how will you even debug it? And Anonymous once said that only half of the programming is coding and other 90% is debugging. A little bit history of debugging. We tend to believe that engineers and programmers have long used of the word bug. And it's something we use on daily basis, and especially from a psychological standpoint, it's very easy to blame some kind of bug than ourselves for taking responsibilities. In the end, we have to face all these bugs because they all ours. And having that said, this page was recorded back then in like 1947, I think. It's the first mouse got stuck in the Harvard Mark II machine. And now it's officially, and it's, I think right now it's in a museum in United States, like as a first actual case of bug being found. So the development is also hard, especially of cloud native applications, because of different factors, which requires from us understanding, logic, passion, acting, and different other things. And also it has one fundamental complexity because of many accidental factors and context issues. So that's why I call it my 8 stages of debugging. And I experience it mostly every day. The first stage that I usually say that can't happen. And next stage usually is it does not happen on my machine, so it works. Next stage that should not happen, why it's happened. Next stage is why does it happen? And like usually we come to, oh, I see the problem. I know how to fix it. I'm very close on it, so I run and try to fix it. Of course, the next stage is obvious. How did that ever work before? And my favorite one, who wrote this shit? And accidentally, I realized, oh wait, it was me. It was me who wrote this code. So, interesting fact that there is many different books and official docs about Kubernetes and other programming languages, but there is no enough information about how to efficiently debug our programs because of lack of experience or knowledge, especially in these new modern cloud environments and or inside Kubernetes. So, as a software engineer, I never get formal debugging education or training, so I had to figure out it on my own. So I would like to ask you, how can I debug or how can you debug running program? So please try to think a few minutes about different ways how we can debug it. So any ideas? Raise a hand or just say loud it. First came to your mind, maybe? Okay, I will help you a little bit. Yeah. Yeah, prints. So like obviously prints. Add prints everywhere and you're done. As someone mentioned, next approach is logs. Yes, add logs and you're done. Any other ideas? It's enough, right? Like print and logs cover everything. If your language has a playground or it's an interpreter language, you can try playground. So you can run something quickly, like in Golang, or in Python, you can just run it as an interpreter and you're done, you can share it. Another interesting idea is to revisit your observation and explain the problem to someone else. In process of someone else is important, but even more important that you're explaining the problem to yourself. As once Kernighan said that sometimes it takes few minutes to realize that never mind, I see what's the problem. This works because teaching someone else force you to find a different perspective between inconsistency, what you're really assuming and what you're doing. Since someone else can be totally passive, you can replace it just with duck, as on the slide. So this technique is called, probably you also know it, a duck debugging technique. And the idea is to just sit and explain problem to the duck, and maybe someone can call, I don't know, a doctor because you're talking with a duck. So it's usually hard to explain people what you're doing. Some programmers even ask explicitly, first discuss it with duck and then come to your colleague to not interrupt from the work. So nice that we have same background of debugging. But last but not least, a tip or like way of debugging. Any other ideas? Maybe more coffee a little bit needs? No? Okay. The obvious one is, of course, using debuggers. This is specific tooling which written for debugging stuff. So just remind it. We will we will discuss it in more details. So, but now let's debug in general. Assuming you have a very simple program written, whatever, in Python, and when you need to debug something on local machine, you just can use your IDE, or you can add a line like I wrote like a breakpoint. So you, like in JavaScript, and yeah, you start debugging session in your CLI or your terminal or you in your IDE, and you can jump around, you can see variables, and you can understand everything, so which is very easy. So on the slide you can see I'm just stopping somewhere before model name condition, so I can, for example, print the value of model name, then I can click next, next, and go through the loop. But we are living in a little bit different world right now. We are living in you wrote it, you build it, you own it, which means we are in containers right now. And it's not so easy like previously, just run debugger locally and debug it. And especially, we use a lot Kubernetes. Can you raise a hand? How many of you using Kubernetes on daily basis? Oh, nice audience. Cool, cool. Yeah, so indeed, not even running containers, we now have this Kubernetes. So we need to go deeper a little bit, right? So, and I defined a problem in the very simple chart. So you can be on the same page, I of course remove all complexity of Kubernetes. So let's imagine you have a black box Kubernetes, which you know is usually schedule a pod, and pod has kind of application, which is maybe Python, Golang, Java, or whatever. And we need to learn how to debug the container because it's not running on our local dev machine, and we can't easily run a debugger. So we need again sit and think a little bit how to do it. But first, let's solve the problem from the top to bottom. So I assume you know some basics, how to check your pod state, and of course how to use kubectl, so I will skip this part. So I made this mind map chart for myself and my colleagues. So like to start from describing a pod and then go deeper depends on the condition. So if pod staying pending, maybe there is no you need more resources, or I don't know, you're trying to bind wrong port. If pod stays waiting, I don't know, maybe we can't pull image from the registry. If pod is crashing, of course, maybe it's unhealthy or something else. And last but not least, important one, pod is running. And it's our target today mostly, and but it does not doing the right things. So it's doing something, but not what we expecting. Of course, one can say delete pod and recreate it, but assume you did it, it didn't work. So what are the next steps? First step is to revisit your init containers. For someone who is not familiar, it's a like idea in Kubernetes. So pod has containers and init containers, and you can run, I don't know, data migration into this init container or check some services are available and then start your main container. And for example, you check logs, nothing interesting, but it's hanging. As you can see, init 1 from 2 is not available. So I have a tip how to debug such containers. So the outcome of init containers, so what we can do, we can temporarily replace command of init container with dummy sleep, and then it will hang, and we can connect using kubectl exec to the container. If you say -c, you will connect to specific container. In your case, it's a init container, and you can, I don't know, run the same command, or you will have some time to debug, I don't know, maybe volumes are mounted incorrectly, maybe you don't have permission for something, maybe network access is broken, etc., etc. There are many ways the problem can be, but the strategy is so you're like replacing with sleep and you are done. Okay, next one is assuming, I have another diagram for you, assuming you have a container image which includes all tools and debugger you need. If question is yes, you can just exec to this container and do your stuff. You can run debugger, you can run netcat, telnet, whatever you need, check something and figure out what's wrong. But in reality, we live in secure world, so our containers are usually distro-less. They don't have anything, no file, no shell, no tools, no debuggers, sometimes not even ls. So the question is no, and Kubernetes has answered to it. The name is ephemeral containers. So it's a relatively new feature starting from Kubernetes 1.18, I think. And this feature was designed explicitly for debugging purposes, and they allow you to inspect the state of the running pod without alerting it. So, and now we have two like nodes. Let's discuss each step one by one. So, and of course, assuming we apply to Kubernetes cluster some dummy manifest, which includes, in my case, it's a Golang app without anything. It only has debugger and application binary, and I just use some environment variables to enable debugging. So what I can do with ephemeral container, first of all, ensure that my Kubernetes cluster support it, and then I can start it. And I can start it using this new command, roughly new kubectl debug, and then your pod name, image, and target. And it will start this container. Here's an example. With my case, I'm reusing the same image, and I'm share processes. These ephemeral containers are useful for interactive, as I already told you, troubleshooting when we don't have permissions, when we don't have insufficient tools we need, and like doesn't have debugger, utilities, or distro-less image. And important that target parameter must be supported by your container runtime. So for Docker it works. There are a few which still does not working, but you can better go and check it on your on Kubernetes documentation side. Okay. So when I do it, and when I did it, you can see Kubernetes will create this new ephemeral container, which has image and whatever. And the session will look like this. So I run PS, and nevertheless, I'm running another pod, another container inside this pod. Because I share processes, the trick is I see processes from another container, which gives me opportunity to do whatever I want. And for example, as a last line, I run Delph Connect. It's a debugger which supports client-server feature. So debugger running in one container, and I run it from another one. And this is a trick. And it opens debugging session, which again gives me ability to set breakpoints and navigate whatever I need. Of course, assuming you build all debugging information inside your binary, because if you remove it, it will not work. And of course, you add some parameters how to do it. I will give you some nice links so you can repeat it on your own in free time. So another idea, you remember we had two like nodes. One is like we create the ephemeral container and share processes, and another one we copy one. So this tip helps you. Sometimes you need exactly same pod as like a target because of different reasons. I don't know. You need to make sure labels are correctly set. I don't know, environment variables or something which includes in main one, but when you run just debugging container with your tools, we just don't have it because we don't copy them. In this case, you can like copy it, connect to it, and do your stuff, which is great in my opinion. Okay, now let's talk about a little bit. Okay, you know the drill, you know how to do it. First question, where I can find debug container? Can I build my own or should I copy someone? So I had same problem. So I made my own debug container, which is includes what I need. I don't want to pull 1 gigabyte image from internet of everything. So I need SQLite, I need Golang, I need Python, I need Vim. I made this debug container. I posted it to GitHub. Every time I need it, I can use it. By default, it has some like network certificate, some processes, and some build code stuff. Again, you can build your own beforehand, and you're done. So using the link, you can try my one. And of course, it has an alias for Docker Hub, so it's same name. When I need it, I just type my name /debug, and I'm done. There is another famous container which is bigger and has exclusively networking tools, or even more, it has performance networking tools. We know networking debugging is hard, and we need right set of tools. And you not always have permissions or network access to install something, so you can just start debugging container empty, and every time you need something, you have to apt-get install, blah blah blah. It's very boring in my opinion, so you can use all pre-existing containers or made your own. So this one is pre-existing. It's really huge, but it's really powerful. Here's an example. I connected to pod, and I can run TCP dump, and I can see how packets are transferring between my interface. So that's the tip. There are many more tools inside this container, and even more on GitHub you can find good like examples and tutorials about every tool. So if you're not familiar, you can go and try what I did, which is nice. Next important step, just in between, is don't forget to burn your git commit SHA into Docker image. Why it's important? Because first of all, if you try to connect your debugger from your local machine to remote container, you have to synchronize code bases. And because we all know we build our image and usually does not include Git folder or anything, you only have a binary. In Golang case, or if it's Python, just bunch of files. So if you add proper git SHA into, so Golang supported, you can inject it directly into binary. In Python, it can be just environment variable. In another language, you can just touch a file inside container, which includes SHA. Then you can easily and adequately run appropriate container and other stuff. Regarding logs, one tip I added in last minute because some people not using it, and I was really surprised that Kubernetes has a concept of replication controllers, which ensures that we run more than one pod if we need it, especially for production. We never run one pod, right? We run usually a daemon set or replica set or something which has duplication. And then when you troubleshoot or try to read logs, you need to find proper pod, and then you need to find to which pod Kubernetes wrote your request from your user, and then you can, I don't know, find something useful or see exception, etc. And here's a tip. Use Stern. It's like a application or CLI tool, and you can tail logs by groups, and then you can grab them. So you can just say Stern app name, and it will tail all logs for all pods in this service or this replica set or something like it, which gives us a very nice opportunity to not ignore it. But of course, if you have a place where you store all logs and you have proper setup, it's unnecessary. You can just find it there using trace ID, but it's another story. Okay. I have a little bit tip for VS Code, but first I will ask you, how many of you are using VS Code? Oh, nice. Okay, that's nice timing. So it's a very quick tip because I showed many debuggers running from CLI, but many people prefer to traditional way like IDE or text editor. So if you want to debug something inside cluster using VS Code, you first, for example, Python application, or for Golang it will work the same. You just need to configure your launch JSON and make sure that VS Code will have opportunity to attach to running debugger somewhere. And then in your Docker file, you just run your application with like wrapper from Microsoft to wrap your Python app and expose port for debugging, which is in my case 5, 6, 7, 8. And then you build it. Of course, it's easy. So you build an image, you deploy it somewhere, you run it in Kubernetes. I run it locally just to demonstration purposes. And as you can see in logs, it waits until debugger will connect. And then you open your VS Code, you click run and debug, you find your launch JSON, and it will connect to your remote pod or locally to your running container. And you can set breakpoints, you can debug it remotely, which is very handy because no need to type in CLI like I do next, 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 or type breakpoint, breakpoint. So it's very handy. Only you need to make sure that if it's inside Kubernetes, you or port forward your debugging port to your local host, or you use kind of telepresence. It's another tool which, when we're developing an application, especially for Kubernetes, we typically, in one single moment, we debug one service. And of course, many people still, I call it CI/CD driven development. So they like build image, push it and try. If it does not work, they change code locally, build image, push and try. So it's super slow. And telepresence solves this problem by running, for example, in my case, telepresent will intercept service name to your local port and send remote traffic from your cluster to your local service instead of service inside remote Kubernetes clusters. Because, of course, you run only single service locally and other services inside, I don't know, staging, and you need them. And then you can somehow remove it and run it locally. But this telepresence will send the traffic to your local machine. And of course, you can just save changes in your VS Code and automatically observe results. No need to rebuild image and other stuff. Last but not least is my favorite tool. Again, I added it also in last minute. People still not everyone are using it. How many of you using K9s? Raise a hand. Nice. How many of you know that you can plug in this K9s? One, no more, three, four. Yes, great. For someone else who don't know it, you can, there is a plugin system and you can add bunch of plugins. And one of plugins I added myself is this debug containers, kubectl debug, which allows me to just by hitting Ctrl H for specific container, so it will copy namespace pod and target and will create and share processes for giving target, and I'm done. Yeah, you can change an image if you want, but it's very handy, no need to type it. Also, it's not on the slide, but I have another plugin which does same for debugging nodes and some other hotkeys which I really love. And of course, you can change everything inside this tool. Okay, we are very much all. So let's summarize. First, the debugger does not fix your bugs. It runs them only in slow motion. So it's only a tool. You responsible to fixing your bugs. And myself, of course. Don't forget to add some details to your images so you can quickly understand which version is broken. Of course, you have to scale down your traffic, otherwise you will have misses of requests to your pod, because if you try to debug something and you have 5 pods, and if you not scale down it, your debugger will not start, because maybe another pod you can't, I mean you can run 5 debuggers simultaneously, but it can be nightmare. Use debuggers as much as possible, and of course automate routine on your daily basis with whatever plugins, hotkeys you like. I have a bunch of links for future reading because it's unrealistically to fit everything. I will share the slides, so I will do it quickly now. So you have a questions, but slides are here, so you can use them. Thanks.
Thank you. So let's move on to questions, Q&A. Anyone?
Don't be shy.
Come on, don't be shy. I think they also might be hungry, so either they might come and find you here or come and find you, ping you during lunch break. Are you here until the end of the day?
I'm here until Sunday.
Until Sunday, awesome.
Yeah, go ahead.
Okay.
So we have a question. I think the guy raised a hand. But we can chat after, okay? Yeah, we decided later.
Stand up and give us your question.
Sorry? Yes. Yeah. Golang works well with Golang. PyCharm, I did not succeed it, but it's another story. Yeah, it works well. You can use NeoVim. So with Golang, it's much easier because Golang does not have any. So Golang, IDE, or VS Code, they all using Delph debugger. And that's why it works perfectly. In Python world, it's slightly differently. And yeah, I can show you same easily.
Okay, I don't see other hands. Anyone?
I hope it works. Tell me if it doesn't work.
Does it work? Have you tried it?
It's a virus, so.
Okay, otherwise you can find him throughout lunch.
Yeah,
thank you very much.
Thank you.
Is an olive tree, Greek olive tree.
Oh, nice.
From the awesome organizing team. Thank you
Is
so
it real?
much.
Is it real?
Of course, yes, of course.
Oh, nice. I appreciate it. Thank you.
Thank you, and thank you for coming out for Devoxx Athens 2024.
Thank you.